Hello everyone, this is our session 10 on differentiation. We were on exercise 1.2, question number 6. Okay, so let us begin with question number 6, the second last question. So exercise 1.2, question 6, we are doing the 9th one now. Okay, so the 9th question says, y is equal to cos cube of cos inverse x cube. Okay, so we can write this function as y is equal to cos of cos inverse x cube. Okay, the whole thing raised to 3. Now what is cos of cos inverse x? It is x. So we are going to use that property of inverse functions, and we say since cos of cos inverse x is equal to x. So we write this as x cube raised to 3, okay, which is x raised to 9. Now we'll do dy by dx. So dy by dx is equal to 9x raised to 8. Okay, this is the answer, the 9th one. Let's go to the next one, 10th question. The 10th question says sin raised to 4 sin inverse of root x. So y is equal to sin raised to 4 sin inverse of root x. It is similar type of question. Yes, so we can put this in a bracket, and then we say y is equal to, we can simplify it as sin inverse of root x. Okay, and the whole thing is raised to 4, which is equal to, again, what do we know about sin inverse? The sine of sin inverse x, okay, is equal to x. So we write this as root of x, the whole thing raised to 4, which is x raised to half into 4, which is x square, right? And so dy by dx of x square will be 2x, right? So here we complete with question 6. Now we are moving on to exercise 1.2, question 7. Okay, what does question 7 say? Differentiate the following with respect to x. So I'm taking the first one of question 7. Y is equal to cot inverse cot of e raised to x square. Okay, this is the function. Now, what is cot inverse of cot theta? So we are going to write it in bracket over here, since cot inverse of cot theta is equal to theta, right? So we can say y is equal to e raised to x square. Now dy by dx is equal to d by dx of e raised to function remains the same, multiplied by d by dx of x square. So this will be 2x e raised to x square. The final answer for dy by dx. This is question 7, the first one. Okay, let's move to the second one. It is y equal to cosec inverse of bracket 1 upon cos of 5 raised to x. Okay, now what is 1 upon cos equal to? It is sec. So cosec inverse of bracket sec 5 raised to x. Okay, so what can we write about this? We can say that cosec inverse bracket, if I want to convert cosec to sec, what do I write it as? 1 second, sorry. So we write this as sec of pi by 2 minus 5 raised to, sorry, just a minute. This will be cosec pi by 2 minus 5 raised to x. What does this mean? Sec theta is a complementary function of cosec 90 minus theta, right? So in brackets you can write over here, since cosec pi by 2 minus theta is equal to sec theta. So I have written this function over here. Okay, now what is cosec inverse of cosec? So that is pi by 2 minus 5 raised to x. How do we get this? Since we can write in bracket cosec inverse of cosec theta is equal to theta. Cosec inverse of cosec is theta, right? So theta over here for us is pi by 2 minus 5 raised to x. Now our function has reduced to y equal to pi by 2 minus 5 raised to x. We'll take dy by dx of this. So dy by dx is equal to pi by 2 is a constant. So that will be 0 minus 5 raised to x, that is a raised to x log of 5. So this is your derivative for the second question. Okay, let us move to the next one. Third question. Third question reads as cos inverse of y is equal to cos inverse of root of 1 plus cos x upon 2. Okay, so what can we write about 1 plus cos x now? So 1 plus cos x is equal to, I'm writing the formula here, 1 plus cos x is equal to 2 cos square x by 2, right? So y is equal to cos inverse root of 2 cos square x by 2 divided by 2. 2 cancels out, you're left with root of cos square, which will be cos inverse of cos of x by 2. Now what is cos inverse of cos x or cos inverse of cos theta? So it is x by 2 bracket. You can write, since cos inverse of cos theta is equal to theta. Okay, y is equal to x by 2. And the last step, dy by dx is equal to d by dx of x by 2, which will be equal to half. Right? So dy by dx of this and this sum will be half. Third sum, cos inverse root of 1 plus cos x by 2. This is the third one. Let's move to the fourth one now. The fourth question says cos inverse of, we have y is equal to cos inverse of bracket root of 1 minus cos of x square. So now the theta itself is x square divided by 2. Okay, now what is 1 minus cos of x square? It is formula 1 minus cos theta is 2 sine square theta by 2. We did one more similar formula in the previous sum, that is called 1 plus cos theta, 2 cos square theta by 2. 1 minus cos theta, it is 2 sine square theta by 2. So now I'm going to use this formula here. Yes. So we are going to get cos inverse of bracket root of 1 minus cos theta, 2 sine square. So 2 sine square theta by 2. So x square by 2 divided by 2. Cancels out. From the root sign, we'll get cos inverse of bracket sine of x square by 2. That is our angle. Okay, now complementary functions have to be used here. So sine theta can be written as cos of pi by 2 minus x square by 2. Okay. Here you can write in brackets, since cos of pi by 2 minus theta is equal to sine theta. 1 second. So you will write cos of pi by 2 minus theta is equal to sine theta. Okay, this is the complementary angle we have used. Now what is cos inverse cos? That is cos inverse of cos theta. So is equal to theta. Pi by 2 minus x square by 2. We have y equal to this. Okay. Also, in brackets we have to mention over here cos inverse of cos theta is equal to theta. Okay. This is a property we have used, so we'll mention this over here. Since now we'll use dy by dx for this function. So dy by dx is equal to pi by 2 is 0 minus half is a constant, x square derivative 2x. So we are left with minus x. That is the answer. Okay, this is question 7, the fourth one. Now we'll move on to the fifth one, question 7, 5. Okay, so question 7, fifth question is tan inverse of bracket 1 minus tan x by 2. Okay, divided by 1 plus tan x by 2. Okay, so what we have to do is we have to convert it into a complete tan function. How will we do that? So we've done this many number of times in trigonometry. We say we just write y equal to over here, right? Tan inverse of, now 1 can be written as tan of pi by 4 minus tan of x by 2, okay, divided by 1 plus tan of pi by 4, which is 1, into tan of x by 2. What does this look like to us? Tan A minus tan B upon 1 plus tan A tan B. What formula is this? It is, I'm writing the formula here. So tan of A minus B is equal to tan of A. The formula would not fit. 1 second. I'm putting it over here. Since tan of A minus B is equal to tan of A minus tan of B upon 1 plus tan A tan B. Okay, which is equal to tan inverse of tan of A minus B. What is A? We have pi by 4 and minus B, that is x by 2, right? So our y function has changed into a tan function. So we can write this as y is equal to tan inverse of tan of pi by 4 minus x by 2. Okay, close the bracket. Now what is tan inverse of tan theta? So it is equal to theta. So pi by 4 minus x by 2. Okay, since tan inverse of tan theta is equal to theta. So remember to write the properties that you're using. Dy by dx is equal to, first is a constant, so 0 minus half. Derivative of x is 1. So dy by dx is minus half. Okay, this is the fifth question. Let's go to the sixth one now. Y is equal to cosec inverse, okay, bracket 1 upon 4 cos cube 2x minus 3 cos 2x, right? 4 cos cube 2x minus 3 cos 2x. Now this is a function, or this is a formula of cos 3 theta. If you remember, cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. Okay, cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. Yes, so we'll use the same formula for the sum we have. So y is equal to cosec inverse bracket 1 upon 4 cos cube 2 theta. So our theta value here is 2x. So 4 cos cube theta minus 3 cos theta is cos of 3, but our theta value is 2x. So 3 theta will be like this. So cosec inverse of 1 upon cos of 6x. Okay. What is 1 upon cos? It is sec. So y is equal to cosec inverse bracket sec of 6x. Okay. Now cosec inverse of sec theta. What we can write this as? Cosec inverse bracket cosec pi by 2 minus 6x. They are complementary functions, right? So in brackets you can write away since cosec pi by 2 minus theta is equal to sec theta. That's why I put it as cosec. Now what is cosec inverse of cosec? It is theta. So pi by 2 minus 6x. Now we have y equal to this since cosec inverse of cosec theta is equal to theta. Now what is dy by dx for this function? First term is a constant, so 0 minus 6. So the answer is minus 6. Clear? So this we are done with question 6 of the 7th part. Okay, now question 7th, the 7th part now. Okay, so what are we doing? Exercise 1.2, question 7, 7th one. Yes? Tan inverse of y is equal to tan inverse of bracket 1 plus cos 3x upon sin 3. Not cos 3x, it's cos of x by 3. It's cos of x by 3 and sin of x by 3. Okay, what we have to do is the function inside the bracket that has to be changed to tan. So tan inverse of tan is what I want to get, right? So how can we do this? Now remember we did the formula for 1 plus cos theta. So 1 plus cos theta is 2 cos square theta by 2. We're going to use this formula over here. So y is equal to tan inverse of, let us put the formula, 1 plus cos theta is 2 cos square theta by 2. So theta where is x by 3, we'll make it as x by 6. Theta by 2 is x by 6, okay, divided by sin theta double angle formula, or you can say half angle formula, where sin theta can be written as 2 sin theta, sorry, 1 second, 2 sin theta by 2 cos theta by 2. This is half angle, right? So can we use this for this? Yes. So we'll write this as 2 sin x by 6 cos x by 6, right? Yes. Now 2 cancels out, cos cancels out. So we are left with y is equal to tan inverse of cos x by 6 and sin x by 6 can be written as cot of x by 6. We'll use complementary angles. So y is equal to tan inverse of tan of pi by 2 minus x by 6, right? Now here in the brackets we write the complementary function that we are using. Tan of pi by 2 minus theta is equal to cot theta, right? So we've used the complementary angle function over here. Now y is equal to tan inverse of tan. What is tan inverse of tan? It is theta. So we are going to write, I'm writing the formula also in the next step. So tan inverse of tan theta is equal to theta. Okay, therefore, y is equal to tan inverse of tan pi by 2 minus 6 will be pi by 2 minus 6. What is the formula we have used? Yes, right? So y is equal to pi by 2 minus 6 over here. Now we'll do dy by dx of this function. So dy by dx is equal to minus 6x will be there. Sorry, minus x by 6 it is. Sorry. X by 6 and so minus 1 by 6 is the answer. Okay, so y is equal to pi by 2 minus x by 6, theta is that, and dy by dx is minus 1 by 6. Okay, so this is question 7, the 7th one. Let's move on to the next one. So we're doing question 7 now, the 8th one. Okay, so the 8th one will be cot inverse of, so y is equal to cot inverse of sin 3x upon 1 plus cos 3x. Right? So how can we solve this now? Either I can continue with cot inverse outside and get tan inside, or I can reverse the function. That is, I can use y is equal to tan inverse of, what is the relation between cot inverse and tan inverse? So we have cot inverse of x is tan inverse of 1 upon x. Reciprocals basically. So tan inverse will become 1 plus cos 3x upon sin 3x. I said you can continue with cot or keep it with tan only. Okay. So tan inverse of 1 plus cos 3x. Now 1 plus cos theta is written as, we have done this formula several times now. So that is 2 cos square theta by 2, so 3x by 2. And sin 3x can be written as 2 sin 3x by 2 cos 3x by 2. Okay. 2 cancels out, cos cancels out. So we are left with tan inverse of cot 3x by 2. Y is equal to tan inverse of cot 3x by 2. Okay, what we can write about cot, we'll write the complementary angle of it so that we get tan inverse tan in the bracket. So tan of pi by 2 minus 3x by 2. Right. What have we used? The complementary angle tan 90 minus theta is cot theta. Okay, and then tan inverse of tan theta is theta. Right. So y is equal to pi by 2 minus 3x by 2. dy by dx will be equal to minus 3 by 2. Okay, this is the 8th one. Okay, let us move to the 9th one. So we have 9th one as tan and y is equal to tan inverse of cos 7x upon 1 plus sin 7x. Okay, now we don't have 1 plus cos theta, we have 1 plus sin theta. So we are going to use a different method. So y is equal to tan inverse of, now what is cos 2 theta formula, or cos theta, you can write it as cos square theta minus sin square theta by 2, that is half angle formula. So let me put down the half angle formula for you first. Cos 2 theta we know as, formula as cos 2 theta is equal to cos square theta minus sin square theta, right? We have cos 2 theta equal to cos square theta minus sin square theta. Now, cos 7x if I want to write. So what will I do? I'll consider 7x as theta. So cos theta will be what? 2 cos square theta by 2 minus sin square theta by 2. Right? So I write it as cos square 7x by 2 minus sin square 7x by 2. So this is your numerator divided by denominator 1 plus sin 7x. So 1 can be written as cos square 7x by 2 plus sin square 7x by 2. Now, why am I writing 7x by 2? Because sin 7x I'm going to write as 2 sin 7x by 2 cos 1 second, cos 7x by 2. So what can we observe in the denominator is a square plus b square plus 2ab, right? So I can write tan inverse as cos square 7x by 2 will be written as cos of 7x by 2 minus sin of 7x by 2. Okay, one bracket. Second bracket, cos of 7x by 2 plus sin of 7x by 2, right? And denominator is square of, or is an identity, so we'll write it as cos of 7x by 2 plus sin of 7x by 2. Okay, the whole square. So one term gets cancelled. So what are we left with over here? Y is equal to tan inverse of bracket cos of 7x by 2 minus sin of 7x by 2, okay, divided by denominator is only plus. So cos of 7x by 2 plus sin of 7x by 2. Okay. Now, dividing, we'll say numerator and denominator by cos of 7x by 2. When I do that, we'll get y equal to tan inverse of bracket 1 minus tan 7x by 2 divided by 1 plus tan 7x by 2, right? Now, what is 1 minus tan theta upon 1 plus tan theta? It is, I'm doing this directly. We've done a similar sum in the previous part of this session. So, it is tan of pi by 4 minus tan of 7x by 2 upon 1 plus tan of pi by 4 tan 7x by 2. So, I'm going to write this as tan of bracket pi by 4 minus 7x by 2. Okay, because tan of pi by 4 is 1. We have done this method just in one of the sums previously. You can check that also. Okay, what is tan inverse of tan? It is theta. So we have y is equal to pi by 4 minus 7x by 2. Therefore, dy by dx is equal to minus 7 upon 2. Okay, here we complete question 7, the ninth sum. Okay. Now, if you have any doubts regarding all these sums that we have done, now you can write to me. I'll solve it again for you. Next session, we finish with exercise 1.2 and move to logarithmic differentiation. Thank you very much.